Hey, welcome. Today we're going to be talking about molarity and how do you solve molarity problems. But first, I want to talk about what you're seeing right now in this short little animation clip that repeats. This is me filling up a couple containers with a drink that I've become a fan of. It's something from Costco that I buy. It's got no added sugar, lots of B12 and other vitamins. It actually tastes great. I'm not making an advertisement for it. I'm just saying, as a random aside, it's pretty good. But I do want to focus, though, right now on the two drinks that you see. Notice the one on the left is going to be less concentrated. The one on the right is more concentrated. That's because the one on the right has a full container of this stuff thrown in, whereas the one on the left has only roughly half a container of this stuff thrown in. So we can use this to our advantage in terms of talking about chemistry, because we can talk about a less concentrated solution, which is what you would see on the left-hand side, and a more concentrated solution, which is what you would see on the right-hand side. There are some other terms that we need to talk about just so that we're all agreeing that we're talking about the same thing. So a solute is the thing that is being dissolved, a solvent is the thing that does the dissolving, and a solution is the mixture where one substance is dissolved into another substance. So what do you think the solvent, solution, and solute is here in this example? Well, in this example, what you can see is the thing that is being dissolved, well, that's the mixture, the mix, the zip fizz stuff or whatever it's called, put into the drink. The solvent, in this case, is going to be the water. That's the thing that does the dissolving. And the solution is the entire drink. So that hopefully can help you to remember what we're talking about here. We're going to build on this and talk about some other ideas. So it is useful to talk about one drink being less concentrated than the other, but it would be way more useful if we could actually put some numbers to that, if we could quantify that or even measure that. And so that's what we're going to go about doing, and that's what chemists do as well. So let's take a look and think about this. So instead, I built on this and did something a little less colorful, but just as important. And in fact, I was able to measure what I was using ahead of time. So I had 2 grams over here on the left-hand side, 5 grams of salt. I'm just using table salt here, which is NaCl, and I'm going to throw it into the 100 mils of water on the left-hand side and the 100 mils of water on the right-hand side, mix them both up, and you end up with 2 solutions, one on the left and one on the right. Again, this one is less concentrated, this one on the right is more concentrated. That's all fine and good, but actually now we can start doing something a little more intelligent and useful with it. We can start quantifying this. This is 2 grams, this is 5.6 grams, and here is going to be our equation for molarities. Let me talk to you about how we're going to use this. We can take something in mass. We can use our molar mass calculations to be able to calculate how many moles of the solute, the thing that's being dissolved, we have. So how many moles of NaCl is 2 grams? Well, we'll solve for that. I'll show you how to do that. If you have no idea what I'm going to be talking about and you need a refresher on how to calculate molar mass, I'll put a link to that lesson in the upper right now. But I will just say that it's really not that tough. I'll show you how to do it. And then the other thing to be aware of is that this is 100 mils down here. The water level's at 100 mils over here as well as over here. Alright, so let's see how to do this calculation. Oh, I do want to remind you that this is the volume of the solvent, the thing that does the dissolving. So let's go ahead and see how to do this problem. This is our equation again that we're using. We're going to go ahead and start writing down the molar mass. This is just straight from the periodic table. For sodium here, chlorine here, so to find the total, we're going to just add both of those together. So the molar mass of NaCl is 58.44 grams per mole. And one other thing that's going to come up, so now we know a conversion factor that we can use to solve for the moles of the solutes, but we also need to know how much volume we're dealing with. Now remember, that was 100 mils that we had talked about, 100 milliliters that we're dealing with. That needs to be converted into liters. We're going to have our solvents measure in liters, so we do the conversion here and we end up with 0.10 liters of solvents in each case. Alright, so let's go ahead and solve for the moles of the solute here. So for the left example with 2 grams, you can do a conversion here, 2 grams of NaCl converting with the molar mass of NaCl into 0.034 moles of NaCl. And so you can do the same thing with the second example on the right hand side over here. We're going to use 5.6 grams and say 5.6 grams, we'll convert that into moles of NaCl. I do that here. We can show the canceling out of our masses as well and changing from grams into moles. So these are our answers for our moles. Now we've got the moles of the solute and we've got the volume for our two different examples. Let's go ahead and calculate our molarity on the next slide where I have a little more room. So we're going to say for our first example, we knew it was 0.034 moles of NaCl divided by 0.1 liters. That will give us 0.34 molar solution is what we say. And that's specifically talking about how concentrated this solution is. Then we do the same thing with the second example over here, and we end up with a 0.96 molar solution of NaCl with the second example, and that just means that it's more concentrated. So that's how you go about solving for one or more of these problems. It really is not all that tough. So in any case, hopefully this has been helpful. If you have any comments, please let me know down below, and I hope you all have a great day. Take care.